for the exam itself. Let me just see how things are going among the peanut gallery online. There's one report, the continuity correction value and associated p-value. Well, it depends. It depends, but for the most part, the continuity, the calculation of chi-square with the continuity correction has a couple of a main advantage of being a more conservative approach, less likely for you to make a dreaded type 1 error. Right? We all know about the dreaded type 1 error now. We don't want to make that. Right? So it's probably more correct with a 2x2 table to use the chi-square with the continuity correction. We're not going to worry about that for our purposes for this test. Okay, you might, and somebody might report it this way. Might report both. This Pearson's chi-square. This is what the continuity correction is, and then we're going to talk about something called Fisher's exact test, and we'll worry about what that is later on. Okay, and I don't see too many other questions there and stuff like that. Yes. Yeah. I'm sorry. How did we do it before? Oh, that was those tables was for evaluating numeric variables. So exactly. So if you're evaluating numerical variables, for instance, if they actually asked people, how many servings of fruit a week do you eat? Right? And some people said 1, some people said 9, some people said 22, some people said 97, right? That you would actually have a number of servings of fruit. Most of this data that we have in the community health survey doesn't have that. There are at least 10 or 15 numerical variables, right? But most of them are categorical variables, category you put them in, right? But if you had numerical variables, what you would be looking at is that for people that have diabetes, what's the average number of servings of fruit that they have? And is that average number different than the average for people that don't have diabetes, right? So in that case, you're using a t-test, right? To compare, whether or not the average for this group is different than the average for the other group. Remember the t-test is the average for group 1 minus the average for group X bar for group 1 minus X bar for group 2 over the standard error. Remember the various ways to calculate standard error. We'll talk about that tomorrow night. That would calculate a t-value for you, and then the t-value you'd want to know whether it was big enough to reject the hypothesis that the two averages are the same. Mu for group 1 is equal to mu for group 2. This is a different kind of variable. So we're using a different analysis and a different way of displaying the analysis and demonstrating whether or not we can reject the null hypothesis. Okay, but it's all dependent on what kind of variable you have. Later on, we're going to be talking about a situation where you have two numerical variables. Like, for instance, let me think of something that might be like that. Okay, let's say that I wanted to see if there was a relationship between BMI and blood sugar level, right? Both of those are numbers. So for patient number 1, we might have a blood sugar level of 150 and a BMI of 28.2, right? Got two values. So I could actually plot them on a graph. And then for another person, it might be a BMI of 21 and a blood sugar level of 90, and so on and so forth. You could plot those points on a graph where the y-axis, say, is the blood sugar level, and the x-axis is the BMI, and make a dot for every person, right? And you could try to see whether there's an association that as the BMI went up, does the blood sugar level go up too, right? That's called correlation, and it's a nasty little stepbrother regression, right? We're going to be learning about that. But that's a different kind of analysis because the data is different. We're dealing with two numerical variables that we want to associate. Okay, when we're dealing with a categorical variable and we want to compare means for, we're dealing with categorical and numerical variable together, and we want to see if the means for the values in that categorical variable are different, right? Then we're dealing with a t-test, confidence interval, and so on and so forth. When we're dealing with categorical data, diabetes, yes or no, aortic stenosis, yes or no, then we use chi-square odds ratio, relative risk, because it's two categorical variables. Numerical and numerical variable, we want to associate them. We're going to be learning a new method for doing that later on, correlation and regression. So it's really the kind of test you use is based on the kind of data that you have, the form of the data, right? Whether it's nominal, categorical nominal, whether it's numerical, or whether it is ordinal. Right? We're not getting into too much ordinal stuff, but that gives you a basic idea of what really the basic that you start with is what is the right test for the type of data that I'm working with. Okay, good. So, oh no, there's only we only suggested 5 topics, and there's 25 of us. So obviously you can do the same topic. Okay, just do it better than them. Embarrass them. It's not it's not a contest. I guess everything's a contest in life, right? When you really get down to it, unfortunately. Right? But look at it as a good-natured contest. Okay, so everybody wins. Okay, so this test is going to be challenging. I know it's going to be challenging because I've done this before. And I know we learned a lot of new concepts. A lot of people are, going to struggle with this and stuff like that. Don't freak out. If you really crash the test, I'll find some way for you to make it up or whatever, right? So our slogan in this class is "No man left behind." Okay, as long as you're doing the work and you're willing, if you have a problem, you're willing to put a little extra work, so you can demonstrate to me that before the end of the semester that you understand these concepts. We're going to get through this course. Okay, so you're going to freak out. Now, the test's going to be difficult, but keep in mind that these screens are right close to each other and stuff like that. So it's very difficult not to glance over somebody else's screen. Your integrity, trust me, as a public health person, is way more important than any particular value that you get on this test, especially since you're going to be able to find a way to fight your way back on the test. Okay, so keep that in mind. So don't freak out over the weekend. I know this is a little bit more challenging than stuff that we were dealing with in the first test. Okay, so I'm going to leave this at that. Tomorrow night, you'll notice that I put in a second half to this session, second half of notes and stuff like that. A lot of it pulled from stuff we've done before, which is examples of one sample t-test, 2 sample t-tests, and so on and so forth. I'm going to go over that online tomorrow night as I'll post the time. And again, it's voluntary. I'll be recording it and posting it later on, so you get a chance to play around with it a bit. Okay, and so I'm going to concentrate tomorrow night on odds ratio, relative risk. I'm going to post a new assignment by midnight tomorrow night, let's say, which is going to include some problems that involve t-test, confidence interval, maybe 1 or 2 things on chi-square or odds ratio and stuff like that, relatively simple. Maybe a couple of SPSS problems or something like that. I'm going to set it up so that you can enter the answers and get feedback right away on them. Okay, that'll be due on Monday night for the exam. At least your first pass on it will do Monday night, same as the exam. So it'll represent kind of a review for the exam, in the form of an assignment, but basically a review for the exam. Okay, the object being that a lot of the problems are going to be similar to the stuff on the exam.